Assalamu alaikum warahmatullahi wabarakatuh. I welcome you all for this class. This is the last segment. This is the last part of this chapter 26. Okay, so this is 26.3 class. Okay, so this is the final class, inshallah. From next class onwards, we'll be doing the next chapter, chapter 27. Okay, so today we are going to see the last topic, which is known as the orbital speed. Okay, so this is the last topic which we are going to see, inshallah, and this topic is mostly it's based on problem solving questions. Okay, so basically, okay, it has a formula. Okay, so you have to apply this formula for answering those problem solving questions. Okay, problems. Okay, so let's see what orbital speed is. Okay, so we discussed about satellites, how these satellites, they revolve around the earth, and what are their purposes. We just discuss, okay, the basic thing, alhamdulillah. And today, inshallah, we are going to discuss more about these satellites and mostly the orbital speed. Okay, it's orbital speed. So what is orbital speed? As the term says, itself says that it is the speed of any satellite. Okay, the speed at which it revolves around the earth. See, orbital speed is not particularly, it is related to a satellite, can be related to also a planet, because even planets, they revolve around the sun in the solar system. Okay, so but the difference between the satellites and the planets is that the satellites, they have the satellites, they vary in their speeds. Okay, they vary in their speed. Some satellites, they have a higher speed, whereas other satellites, they have they revolve slowly. Comparatively, they are slow. Okay, but whereas the planets, they don't, they don't have their they don't change their their speed. The speed is always constant. Okay, you know that a solar system is a very it has a lot of precision. It runs in synchronization, nothing changes whatsoever. Okay, the orbital speed, the position of each and every planet on its orbit is always the same, it's constant. Okay, so the orbital speed of a satellite, okay, it depends on one thing which is very important, okay, to mention here. It's there in your textbook. Okay, so as you know that satellites, they are put into the orbits by people for various purposes. For example, for communication, mobile communication, and monitoring the weather, and also monitoring the temperature of the surface of the oceans, and so on. So there are various purposes. Okay, so now these satellites, they are put into different levels in the atmosphere and at the surface of the earth. Okay, so for example, a satellite for communication, okay, they are put in high orbits. Okay, and they travel. Okay, and these high orbital satellites, they travel at approximately 3 kilometers per second. Okay, while those observing the whole surface of the earth are put into lower orbits with speeds of 8 kilometers per second. Okay, so those who are at the lower levels, okay, at the lower polar orbits, okay, they revolve with the speed of 8 km per second. Okay, whereas those who are put in high orbits, they travel, that is, they revolve at the speed of 3 km per second. So that means that comparatively, those satellites which are put in lower orbits, they travel much faster than those satellites which which are put in higher orbits. Do you understand? Okay, so this is a very important concept that you have to remember. Okay, so just in case if you get a question in the exam, you have to write this point regarding what on what factors does the orbital speed of a satellite depends on. If they ask you such questions, you have to mention this very important point. Okay, so this is what is orbital speed. I hope that you have understood this concept. Okay, let's move on to the next slide. Now this slide tells you the formula for orbital speed. So what is the formula of orbital speed? Orbital speed equals 2 into pi into orbital speed over, that is divided by time period. Okay, so v equals 2 pi into r is radius, orbital radius, divided by t. Okay, so this seems okay, similar to the speed, the speed formula. What is the speed formula? Yes, that's right. Speed equals distance over time, that is distance divided by time. So this is just like a speed formula, but one change. Okay, that is distance has been changed to 2 pi multiplied by r. Okay, so this is a very important point. Just in case if you forget, you can recall this formula. Okay, relating with the speed formula. Okay, now let's look into the units. See, orbital speed is always in meters per second. Okay, it's always in meter per second. Okay, so that is, this one is always written down in terms of meter per second. Okay, so then orbital radius is always written down in terms of meters. Okay, then time period, it's always written in terms of seconds. Okay, so this is very, very important when you do the problem. Inshallah, you have to remember that you have to bring the answers, the final answers, in accordance to these units. Okay, you don't have to write in some other units. Okay, so this is the only right way. Okay, right. So now we yeah, see, of course I'll help you to understand how to do the problem. Inshallah, we'll be seeing in this video, inshallah. But let me tell you in advance that this is your homework for today. Okay, so this is your homework for today. That is, these two questions, these are the book pack questions. You don't have to worry, these are the book pack questions, chapter questions, just there in page number 264. Okay, it's there in 264. So you just have to write the answers, that is, you have to work these questions number 3, question number 4, in a separate notebook, and just scan this and send me through Google Classrooms. Okay, send me through Google Classrooms. Inshallah, I'll check all those steps which you have written down, and also the final answer. Okay. Okay, so from next slide, inshallah, I'll teach you how to simplify, how to solve these problems. Okay, so I'm gonna work it out on paper. These two questions I'm going to work it on the paper. Okay, so on the paper I'll not be writing the questions because the questions are too lengthy. Okay, so I'll be just working out the questions with very important tips for you, so that it makes you easier to solve the problems. Okay, so when I'm doing the questions, when I'm doing the the problems, if you have a doubt regarding the question, you may just reverse or rewind the video, and you can check out the questions. Okay, so let's go ahead and let me work out for you the questions. Okay, inshallah. Okay, students, this is your work example which is there in your textbook, page number 264, chapter 26, astrophysics. Okay, so let me brief you, let me explain you the working. Inshallah, this will give you a broad picture how to do this particular problem. Okay, so I request you to take page number 26 in your textbook. Okay, if you don't have your textbook, then that's okay. Okay, just watch the video and try to understand the concepts. Okay, so the question says, calculate the speed of a satellite that is orbiting 200 kilometers above the Earth's surface and completes one orbit in 1 hour 24 minutes. The radius of the Earth is 6,400 kilometers. Okay, so this is it. This is the question. Okay, from here it's the is the workout with the explanation. Okay, so what is the formula for this question? What is the formula which we are going to use to solve this question? The formula is here: orbital speed V equals 2 into pi into r divided by t, which is the time. Okay, so r is the radius, t is the time, and v is the speed, the orbital speed. Okay, right. So now in this kind of question, you have to do two conversions, basically two little conversions. Okay, so what is that? That's nothing but number one is your radius of orbit, that is the distance actually. Okay, so in the question the given distance is 200 kilometer. Okay, so the satellite orbits about the earth's surface. Okay, and this is the distance which has been given, and also there is one more distance which is given also in the question, which is the radius of the earth, which is 6,400 kilometers. Okay, so what you need to do is simply you need to add these two distances, because as the description says, the radius of the earth is measured from the center of the earth. That is, it is the radius of the earth plus the height of the orbit above the earth's surface. Okay, so which is the radius of the earth? This is the radius of the earth. Okay, 6,400 kilometers. And what is the height of the orbit above the earth's surface? This is the height above the earth's surface, which is 200 kilometers. Okay, so what you're doing here is the first conversion. What you're doing here is first you need to add these two. Okay, these two distances. This is what it is shown here, 200 kilometers plus 6,400 kilometers. Okay, gives you 6,600 kilometers. Now a very important conversion here, okay, which you need to do is you need to convert this kilometer into meters, because we already discussed in the formula the final answer is mostly in meter per second. Okay, meter per second. Okay, so for that you need to convert it into meters. This kilometers you have to convert into meters. Okay, so what you need to do is you need to multiply this answer with 1,000. Okay, then you get this answer. Okay, this final answer, this is in meters. Okay, right, so this is 66 lakh meters. Okay, so this is the final answer after the conversion. Okay, this is number one step you need to do with the conversion. Okay, and number two step, what you need to do is you need to convert this time, which is in hours and minutes, okay, into seconds. See, whatever time parameters you get, for example in hours, in minutes, or in days, you have to convert it into seconds. Okay, you don't have to think twice, just you have to convert it. See how it is done. 60 minutes, because why? Because 1 hour equals 60 minutes plus 24 minutes. You don't have to write directly here 1 hour, just write in terms of minutes. Okay, then you have to multiply this with 60 seconds. Because why? Because each minute, okay, it consists of 60 seconds. That's why multiplied by 60 seconds, and this is the answer, 5,040 seconds. Okay, so now you have to apply this value and this value in the formula. You have to substitute these values in the formula. So this is your r, and this is your t. Okay, so when you substitute these values, you have to simplify. Okay, then you get your final answer, which is there in 8,200 meter per second. Sometimes in the exam they might even ask you to show your answer in kilometers per second. You just have to convert this answer which is in meter per second into kilometer per second, and that's it. Okay, so that is simple as that. Okay, boys and girls, I hope that okay, so now I'm going to work out this question. This is question number 2, which I showed you in the slide. Okay, even this is also a very important type. Okay, so this is another variety of the same kind of problem. Okay, so the difference is in the previous question it asked you to find out the orbital speed. Now here in this question you're asked to find out or calculate the orbital time. So that is, you have to find t here. Okay, so let me read out the question here. it says calculate the orbital time of a satellite that has a speed of 3075 meter per second and height above the earth is 35,906 kilometers. Okay, so the radius of the earth is already given here. It's 6,378 kilometer, the same. Okay, so obviously we are going to use the same formula. Okay, so orbital speed v equals 2 pi r divided by t. Okay, now what we are going to do is we are just going to interchange. Okay, so this value is going to go here and this is going to come here, so that is t is going to go here and v is going to come here. That's it. Okay, so this is how we have to rearrange the formula. Okay, so this is how we rearrange the formula, and now it's very important that we find out the values which we have to substitute here in the corresponding parameters. Okay, so what is r? Okay, r is the radius. Okay, so now again we have to add, that is we have to do the same step number one, that is we have to add these two, then we have to convert this into meters. Okay, so how do we do that? It's very simple. You just have to add these two. Okay, 35,906 kilometers plus 6,378 kilometers. Okay, so what is answer? Okay, so it gives you somewhere around 42,284 kilometers. Okay, so now comes the conversion. Okay, so how do you convert? Just multiply this with 1000, you get the final answer, which is 42,284. Okay, just added with 3 zeros, additional 3 zeros. Okay, now it's in meters. Okay, so this is the final answer. So this is the r, we got the r here, so we just let us just substitute v equals 2 into pi into 42284,000. Okay, so this is in meters divided by v. So what is v? We have to do conversion here? No, because we directly have the speed here, which is 3075 meters per second. Okay, so just have to substitute here directly. Okay, so that's too easy, right? Okay, so then we simplify, and what we get is this value, 86,400 seconds. Okay, in seconds. So this is the final answer. See, for example, in the question, if they ask you to give the answer in minutes or in hours, again you have to further convert this. Okay, so when you convert the seconds into minutes, you get this answer in minutes, and again further if you convert this into hours, then you get 24 hours as the final answer. Now the question is, how do we convert it? That's very simple. You just have to divide this by 60, and also this minutes, if you want to convert it into hours, again you have to divide it with 60. You get this final answer, 24 hours. This is the final answer. So this is how you are going to do this problem. Alhamdulillah, I think that you have understood the concepts. Okay, so this is the end of today's class. Okay, so I request you to write the questions in paper, scan it with your mobile phone, and send the file in the Google Classroom page. Okay, so I think you have understood all the concepts which I have taught you today. If you have any doubt, you can always contact me. Okay, but don't send messages if it's not emergency. Okay, assalamu alaikum wa rahmatullahi wa barakatuh.